Right now, at this exact moment, the world's most powerful ground-based observatories are keeping a secret that threatens to dismantle the institutional credibility that gives astronomical science its authority. Humanity is standing at the edge of a discovery so fundamentally irregular that the senior astrophysics community has collectively chosen silence over transparency. The object designated 3I/Atlas is not approaching our inner solar system. It has already arrived. What the raw tracking data reveals about its composition, its trajectory, its physically impossible rotation, and most critically, the existence of what researchers are quietly calling the 15th anomaly, builds a statistical case suggesting that what our civilization is witnessing cannot be reconciled with any known model of natural celestial mechanics. In less than 24 hours from this moment, this object achieves its closest approach to Earth, and nearly everything the public has been told about its identity has been shaped by institutional necessity rather than unfiltered observational evidence. From the Atacama Large Millimeter Array stretching across the Chilean highlands to the Keck Observatory in Hawaii and the Very Large Telescope Complex in the Paranal Desert, every single monitoring station tasked with characterizing this visitor has confirmed measurements that the mainstream astronomical establishment cannot reconcile with existing physics. The silence surrounding those measurements is deafening precisely because the data itself is screaming. What public consciousness has been told about 3I/Atlas is that it represents a rare interstellar visitor, perhaps an Oort cloud fragment or a rogue comet ejected from a distant stellar system billions of years ago. That narrative is comfortable and containable, preserving the existing structure of astronomical authority without demanding any uncomfortable institutional recalibration. But what the raw astrometric data actually demonstrates is something far more difficult to absorb. The object executed a gravitational maneuver so precisely calibrated that the statistical probability of it occurring through entirely natural processes registers at just 0.2%. Let that number settle for a moment. When an object enters our solar system from the interstellar void, it encounters an immediate and overwhelming gauntlet of gravitational forces. The Sun's gravity well dominates the entire inner system, while Jupiter's massive field creates regions of chaotic and unpredictable interaction. Standard physics predicts one of exactly two outcomes for any object arriving from beyond the heliopause: either capture and an eventual collision with the solar furnace, or chaotic ejection along a random vector bearing no geometrical relationship to the ecliptic plane where Earth and the other planets conduct their orbital cycles. This is not theoretical speculation. It is observational reality confirmed across centuries of astronomical tracking. Random interstellar objects arrive on high-inclination orbits, coming from above or below the planetary plane in chaotic and natural trajectories. 3I/Atlas did not behave like a natural interstellar visitor. According to the observational data compiled across 147 continuous days of tracking, this object executed what can only be accurately described as a precision gravitational assist maneuver. It dove toward the Sun, then used Jupiter's gravitational field not as a chaotic obstacle, but as a deliberate navigational anchor, threading the very boundary of that gas giant's hill sphere, the precise region where planetary gravity transitions from domination by the Sun to domination by Jupiter itself. To accomplish that maneuver naturally would require advanced knowledge of our solar system's complete gravitational topology from light years away or something else entirely driving the trajectory alignment. There is no comfortable third option hiding between those two possibilities. The result of that maneuver was extraordinary, placing the object into an orbital path aligned with Earth's neighborhood along the ecliptic plane to within 5 degrees of accuracy. For a random interstellar visitor, the statistical probability of achieving that degree of trajectory alignment without active guidance calculates to a vanishingly small 0.0022%. That is merely the entrance ticket to a far stranger set of physical impossibilities waiting deeper in the tracking data. Natural comets move through the cosmos with no preferred directional orientation. Their rotation axes point randomly upward, sideways, or diagonally because the chaotic, turbulent conditions of their formation imprint no directional instruction whatsoever. This lack of alignment is not a contested point in planetary science. It is one of the most reliably confirmed observational facts in the entire historical catalog of cometary visits to our inner solar system. Standard physics predicts random orientation, and centuries of recorded space tracking confirm it without exception. There is simply no known natural mechanism in astrophysical literature that selectively aligns a comet's spin axis toward any specific celestial body. Yet, when researchers examined the rotational characteristics of 3I/Atlas using high-resolution spectroscopic analysis combined with photometric light curve observations, they uncovered something sitting entirely outside the established boundaries of laboratory physics. The object's rotation axis points directly toward the Sun. It does not point approximately toward our star, nor does it sit in the general solar direction with a wide margin of imprecision. With measurable, documented accuracy, the spin axis of this object remains oriented squarely toward the Sun. The probability of a random interstellar comet achieving that specific degree of rotational alignment to within 8 degrees of precision calculates to just 0.5%. When that figure is combined with the already extraordinary trajectory alignment probability, the compounding statistical picture causes the natural object hypothesis to collapse entirely under its own mathematical weight. Rotational alignment is merely the structural foundation for what global observatories detected next, a phenomenon that drove senior astrophysicists into carefully worded public silence and urgent private conversation. As tracking stations followed 3I/Atlas toward perihelion, the point of closest solar passage, they identified a structural feature with no precedent in the recorded science of cometary behavior: collimated jets. Rather than the broad, diffuse plumes of sublimating ice that natural comets reliably produce, or the scattered outgassing that occurs when solar radiation strikes randomly distributed ice deposits across an irregular rocky surface, these were focused, narrow, and geometrically precise particle beams. The jets forming the anti-tail, the emission structure pointing directly toward the Sun rather than trailing away from it, maintained their tight collimation accuracy across a distance of 500,000 kilometers. In fluid dynamics, a beam of that length and tightness represents a tightly controlled stream. In rocketry, that distinct geometric signature belongs exclusively to a precision nozzle, an engineered aperture designed to direct material output along a specific and sustained vector. The statistical probability of jets forming that specific shape through entirely natural processes, operating on random ice deposits, sublimating across an uneven surface, calculates to just 0.0025%, or 1 chance in 40,000. Stack those probabilities together and the picture becomes undeniable. Multiplying the trajectory alignment figure by the rotation axis alignment and the jet collimation probability yields a number that does not merely suggest something unusual. It crosses directly into territory that formal risk assessment and actuarial science classify as mathematical impossibility. The combined probability that all three characteristics emerge simultaneously from natural processes operating on a random interstellar visitor calculates to approximately 1 in 4 billion. In professional risk assessment, events with a probability lower than 1 in 1 million are not classified as merely unlikely. They are treated as effectively impossible for all practical analytical purposes. At 1 in 4 billion, we have moved so far beyond that threshold that the mathematical distance itself becomes difficult to conceptualize. Yet, this object is real, fully measured, and arriving right on schedule. Beyond these physical traits lies a 15th anomaly, the impossible characteristic sitting in plain sight inside the spectroscopic records that global observatories accumulated across 147 days of continuous observation. What this final anomaly reveals about the elemental composition of 3I/Atlas completely dismantles every working assumption about what a naturally occurring comet can be. When automated spectrographic analysis systems at the European Southern Observatory first flagged an anomalous nickel abundance signature, the initial institutional response was to classify the reading as simple instrumental error. That explanation did not survive contact with data gathered independently by other global facilities. The abundance of nickel detected in the reflected light spectrum of 3I/Atlas registered at levels 47 times higher than the typical elemental composition of carbonaceous chondrite meteorites, the class of space objects most chemically similar to primitive cometary material. A 47-fold increase is not a minor measurement deviation. It represents a completely different category of physical object. Natural comets are composed predominantly of water ice, silicate dust, and trace organic compounds, with elemental ratios precisely documented across centuries of spectroscopic observation. When measuring nickel content in standard interstellar visitors, scientists expect concentrations at parts per billion levels, trace abundances consistent with the primordial chemistry of an early stellar system. What spectrographs detected in 3I/Atlas was fundamentally different. Nickel ratios consistent with industrial-grade stainless steel or Inconel superalloy compositions, materials that do not form through natural astrophysical processes but are manufactured. The probability that a natural comet would possess this specific elemental architecture, featuring this precise ratio of nickel to iron to chromium, calculates at approximately 1 in 100 million. But the nickel abundance is only the opening paragraph of what the composition data contains. The object also demonstrates anomalously elevated concentrations of titanium and molybdenum, elements rarely found in significant quantities within naturally formed cosmic bodies. The combined elemental signature reads less like a relic of primordial stellar chemistry and more like the output of a material science engineering process specifically optimized for high-temperature stress resistance and corrosion protection across extreme operational environments. When researchers cross-referenced this compositional profile against aerospace alloy specifications from NASA and European Space Agency technical databases, they did not find approximate matches or loose correlations. They found direct material composition alignments with heat-resistant superalloys used specifically in spacecraft propulsion systems and thermal shielding applications. The magnitude of that discovery forced a strategic decision on the astronomical community: acknowledge the data publicly and accept institutional scrutiny, or maintain disciplined silence and restrict raw spectroscopic files to internal networks. The choice that was made is clearly visible in what you are not reading in mainstream science publications right now. The collimated jets, those precisely focused particle streams emerging from the object's surface, compound these compositional findings with behavioral evidence that passive outgassing physics simply cannot accommodate. When the velocity vectors and particle momentum transfer recorded by infrared detection arrays are analyzed in detail, the energy expenditure required to sustain those jets exceeds what natural sublimation can produce by a significant margin. Natural comets generate their characteristic diffuse plumes because ice sublimates chaotically across randomly distributed surface depressions at irregular rates, producing wide, unfocused, and directionally unpredictable outputs. What 3I/Atlas produces is structurally different in every measurable parameter. The jets originate from what the tracking data characterizes as precisely engineered apertures, nozzle-like openings from which material emerges in controlled directional streams that maintain their geometric consistency across extended observation windows. The antitail maintains its precise orientation through what appears to be continuous active emission rather than the sporadic, intermittent outgassing expected from rotating chunks of sublimating ice responding passively to variable solar radiation. Furthermore, the spectroscopic breakdown of that jet material reveals a surprisingly clean signature dominated primarily by nitrogen and water vapor, a chemical combination consistent with cryogenic propellant systems undergoing controlled venting or directed discharge. Cryogenic propulsion systems. Those words carry implications that stretch far beyond the comfortable vocabulary of traditional cometary astronomy, and the scientific community knows it. That is precisely why those words are not appearing in any peer-reviewed journal covering this object. Pulling all of these individual threads together simultaneously leaves a picture that admits only one logically consistent interpretation. If the collimated jets represent the exhaust signature of an active propulsion system, if the elemental composition of the object matches industrial aerospace superalloys, if its trajectory demonstrates navigational precision that natural processes cannot statistically generate, and if its rotation axis maintains a strict alignment with our Sun, then what is arriving is not a comet. It is not a natural visitor from a distant stellar system, but something that crossed the interstellar void under conditions and through mechanisms that current scientific frameworks have no honest category for. The institutional silence surrounding 3I/Atlas is not, at its core, scientific caution. Scientific caution produces qualified statements, published uncertainty ranges, and public acknowledgement of anomalies pending further investigation. What the astronomical community has produced around this object is something structurally different, a coordinated absence of public engagement with the most consequential observational data in human history. That absence is driven by existential fear, because the moment any senior scientific institution publicly states what the spectroscopy, orbital mechanics, composition analysis, and jet characteristics unambiguously demonstrate, they are forced into an unavoidable public conclusion. Humanity is not alone in this universe, and something built by another intelligence has just executed a controlled entry into our planetary neighborhood. At its point of closest approach, 3I/Atlas reaches a position 26 million kilometers from Earth. At that moment, something humanity has theorized about for centuries transitions from philosophical abstraction into documented physical reality. The object is positioned far enough away to pose no direct threat to our planet's surface, yet close enough for detailed imaging by every major observational facility currently pointed at it. But distance does not diminish the significance of what that arrival represents. What observatories detect during this observation window will either reinforce the natural comet narrative that institutional channels have been carefully maintaining, or it will shatter that narrative in ways that no subsequent press release can reassemble. According to the tracking matrix, the 15th anomaly that has been whispered about in closed scientific conferences becomes impossible to dismiss at closest approach. The elemental composition remains unchanged by proximity to our Sun, while the collimated jets continue their directed emission without the chaotic variability that solar heating would produce in natural ice deposits. The rotation axis persists in its strict alignment with our star, confirming across 147 days of continuous observation that this is not a natural object following natural laws. The profound question facing our civilization at this moment is not whether 3I/Atlas is artificial. The accumulated data has already answered that question with a statistical certainty that transcends reasonable scientific doubt. The true question is whether humanity's institutions will publicly acknowledge that answer. Will peer-reviewed journals publish the spectroscopic findings in full? Will space agencies release the complete orbital mechanics analysis to the scientific community and the public simultaneously? Will the astronomical establishment break its carefully maintained silence and formally acknowledge that our instruments detected and characterized extraterrestrial technology passing through our solar neighborhood on a controlled trajectory? The historical record of how institutions handle discoveries that threaten foundational assumptions offers a sobering template for what happens next. Natural bolides and routine cosmic impacts are regularly absorbed into public memory without triggering any fundamental reassessment of our place in the cosmos. The pattern remains consistent and well established across history. Observe, measure, analyze, and then redirect public attention before the broader implications have time to settle into collective consciousness. But there is a critical difference between those previous natural occurrences and what the data surrounding 3I/Atlas has produced. Routine space debris offers no spectroscopic anomalies, no collimated jets with thrust profiles inconsistent with natural sublimation, and no trajectories registering 1 in 4 billion probability signatures. Previous events were startling, but ultimately classifiable within existing natural frameworks. 3I/Atlas has generated no such comfortable classification pathway. Every independent analytical approach applied to its observational data, from orbital mechanics and rotational dynamics to elemental composition, jet behavior, and energy expenditure, arrives at the exact same destination through a different route. That convergence across multiple independent lines of evidence is precisely what makes institutional silence increasingly difficult to sustain as closest approach arrives. The raw data persists regardless of what official channels choose to publish or withhold, and those spectroscopic records cannot be unwritten. Somewhere within secure research archives and the servers of observatories that have been quietly accumulating the most consequential dataset in scientific history, the evidence sits permanently recorded. The tracking data confirms that on this trajectory, humanity's instruments recorded the presence of intelligently engineered technology executing a controlled gravitational maneuver through our solar system. Not through dramatic radio contact or hostile interaction, but through orbital precision, material composition, and propulsion behavior that natural astrophysical processes cannot generate at any statistically meaningful probability. What makes the behavioral evidence particularly difficult to rationalize away is its unwavering consistency across time. Natural phenomena, especially those driven by thermodynamic processes like ice sublimation, exhibit inevitable variability due to irregular solar heating and uneven surface composition. The jets produced by 3I/Atlas show none of that expected variability, maintaining their tight collimation and sustaining their emission geometry with a consistency that thermal and chemical processes operating across an irregular surface simply cannot replicate. The clean nitrogen and water vapor composition of the jet material fits a cryogenic propulsion interpretation far more cleanly than the chemically complex mixture of volatile organic compounds typical of primitive cometary ice. Combined with the superalloy composition of the surface material, this represents a convergence of evidence that the natural comet hypothesis cannot absorb without complete structural failure. What civilization faces in this window surrounding closest approach is therefore not simply a scientific question about the nature of one unusual interstellar object. It is an immediate stress test of whether human institutions possess the capacity to process and communicate a discovery that invalidates the foundational assumption of cosmic isolation upon which modern scientific and philosophical self-understanding have been built. Removing that bedrock without preparation risks cascading institutional failure across systems never designed to function without it. If you want to stay ahead of the narrative as this unprecedented discovery continues to unfold, subscribe to the channel, hit the notification bell, and leave your thoughts in the comments below on how humanity should handle the truth.